Hello everyone, this is our project of Mechanism Sessional for tutorial number 5. My name is Rakshit Raj, 22ME10069.
And my name is Alina T, 22ME30009. This is a problem statement, dumper truck with automatic door opening mechanism. So we have come up with a model that would have a door closed in the initial configuration. As you can see here, this is the initial configuration when the door is completely closed. And as the bin tilt angle is increased, the door opens automatically. This is an intermediate configuration, as you can see when the door starts opening. Now let me guide you through the synthesis of the whole model. As you can see here, this is the 4R mechanism that is involved in the opening and closing of the door. So let us look at the links that are involved in the 4R mechanism here. This is the ground link which is attached to the chassis. This is the door. This is the bin, which acts as the fourth link, and this is the link connecting the ground and the door. This model, as you can see, is primarily run by the 4R mechanism that you see here. This 4R mechanism only leads to the opening and closing of the door. Now let us look at the synthesis of this 4R mechanism. In order to synthesize this 4R mechanism, we have had to assume a few values. Those are the dimensions of the bin and the distance between the ground hinges A and O and the maximum door opening angle. For this, we had to refer to a few of the real life models, and we have scaled down the values according to our convenience. The values that we have assumed are the dimensions of the bin, which is CO, and the fourth link 150 millimeter, CQ, which is 320 millimeter, the distance between the ground hinges A and O, which acts as the first link L1, and that is 50 millimeter. As you can see here, this is the angle created by the door with the bin, which is alpha at any intermediate position, and the maximum value that we have assumed for alpha is 75 degree. Now let us look at the geometry that is involved. Initially, we are considering this configuration, which is a dead center configuration. And in the dead center configuration, link L2 and L3 are collinear. And here, when we are considering this triangle AOC, the lengths AO and OC are already known from our assumptions, and we are trying to figure out the value of L2 plus L3. For this, we'll be using the properties of the triangle, and we can obtain the value of AC, which is L2 plus L3, to be this value. Since the value of L1 and L4 are already known, and this angle we can find out as 90 degree minus alpha max, which is 75 degree. This is possible because um, the door, which is a rigid link, is BCG, and the angle made by BC with CG is 90 degrees. So the angle here is obtained by 90 degree minus alpha max. Now let us consider an intermediate configuration for the further steps. So in this configuration, you can see that BC is parallel to the ground and the CO is perpendicular to the ground. And we are considering the triangle AHB here. For that, the side AH is known, which is, the side AH is L3 minus L1, the side BH is L4, and AH is L2, and we'll be applying Pythagoras theorem, as you can see here, from which we can obtain a relation uh, we can obtain an equation involving L2 and L3, and from equation 1 we were able to obtain the value of L2 plus L3 using the equations L1 and L2. Now we can find the values of L2 and L3 separately to be these values. So with this we have come to an end of the synthesis process.
Now I will be explaining you about the relation between the angle of the gate opening angle and bin tilt angle. So here theta is the input bin angle, alpha is the gate opening angle, beta is the angle between link 2 and ground, while theta 1 is angle made by link 3 with respect to the ground. So using the geometry, we finally arrived at this relation between beta and angle theta, where A, B, C are all mentioned in terms of degrees and lengths of the links. The final relation between theta 1 and alpha is this. So we use this relation to code it on MATLAB, for which we used for simulating the working mechanism and also plotting the graph between the bin angle and the angle of the container. So let me take you to the MATLAB code. So in this code, we first initialized the values of L1, L2, L3, and L4, which we got from the synthesis process. And then we initialize the figure and the plot for the simulation of working mechanism. When then we initialize the objects which are to be plotted, that are the links and the joints, and finally we use the loop for the animation. And after each iteration we were updating the joint positions, which gave us the following output. So let's see the output. So this simulation of working mechanism starts from the closed position and will go till the dead center configuration. And this is the graph of input bin angle versus gate opening angle, and we can see that this graph is linear to till about 20 degree, but after that it takes a non-linear configuration. The reason behind this non-linearity is the involvement of trigonometric functions in the relationship, and also it generally happens when we reach the singularity configuration or the extreme position configuration. So this was the plot which we got from MATLAB. Now let me take you to the SolidWorks CAD which we built. This is the initial position and this is the dead center configuration of the CAD. So let me take you to the SolidWorks window. So this is the model which we had built. This is the container, this is the chassis of the truck, and this is the lid. These are the links joining the ground and the door. We have also used an hydraulic mechanism for increasing the container's angle with respect to the ground. We can see that as this hydraulic pushes the container towards up, the link of the door automatically opens it, and the maximum angle reached is 75 degree with respect to this container, which we had seen in the synthesis process. Let's see the exploded view once. So these are the links, the four links, and one is the ground link, which will be connected here and to the container. Let's see the animation of the working of our CAD. So we can see the hydraulic taking the container towards its extreme position. So this was it from our side. Hope you liked the presentation and it was insightful. Thank you.
Thank you.